Yes, ma'am.
See, v square, we have to prove that this equation, third equation, and here we have a particle which have a initial velocity u at t equals to 0, and after time t, it contain velocity v, and it is moving with a constant acceleration a. We know that a equals to dv upon dt. Now we have to multiply by ds and divide by ds. Okay. So mathematically we can do this. Now we know that ds upon dt is a formula of velocity. V equals to ds upon dt. We use the same formula in the second equation, v equals to ds upon dt. So we can put v in the place of ds upon dt. Okay. Now we can write like this. We can write this equation like this: a into ds equals to v into dv. Is there any problem in this step? सिंपल मैथमेटिक्स है, अभी कुछ इसमें फिजिक्स नहीं पढ़ाई है, सिर्फ ds का मल्टीप्लाई किया है, ds से डिवाइड किया है. Now we know that ds upon dt equals to velocity, so we just put the velocity here and just multiply this ds here. A ds equals to v into dv. Okay, we know that v equals to ds upon dt. So I'm just putting the value of ds upon dt here. Okay, now this ds comes here. A dot ds equals to v dot dv. Is this equation clear?
Yes, ma'am.
We know this formula dv upon dt. We are just multiplying ds and dividing ds. Okay, simple mathematics. When we cancel out this ds, we will get dv upon dt. Okay. Now we know that ds upon dt is the formula of instantaneous velocity. So we can put this v here. Okay. Now the simply multiply this ds here. A dot ds equals to v dot dv. Now integrating both sides. Okay. For integration, we have to apply sign of integration. Okay. Now for integration, we have to apply limit also. So let's talk about the limit of displacement. At t equals to 0, displacement is also 0, right? And after time t, the displacement is s. We are considering that after time t, the particular particle travels distance s, displacement s. Okay. Now when we are talking about velocity, initial velocity is u, and after time t, the final velocity is v. Now let's integrate. A behave like a constant for this because here in the function we don't have same kind of variable in function and derivative. So the a behave like a constant, so just take out the constant. Here v behave like a function because v, and we have to integrate v with respect to dv. So we will apply the formula of integration, that is xn equals to xn plus 1 upon n plus 1. So here the power of v is 1, so we will apply 1 plus 1 upon 1 plus 1, and the limit is v and u. Okay. Is this clear? Now here is nothing, so we can consider 1. So we will get s, and the limit is 0 to s. Here we can write like this: v square upon t v u. Okay. So a s minus 0, upper limit minus lower limit. I told you that we can't apply limit on constant term. So just take out 1 by 2 like this and apply the limit on v square. So we can write like this: as equals to 1 upon 2, and here upper limit, that means v, minus lower limit, that means u. So just write like this, v square minus u square, v square equals to u square plus 2as. This is your third equation. See this equation very carefully. What we are doing, we are integrating both sides, and here we are applying the limit of displacement. At t equals to 0, displacement is 0. After time t, it covers displacement s. At t equals to 0, the initial velocity is u. After time t, the final velocity is v. Now simply integrate this. A behave like a constant, take out the constant. Here is nothing, so we will consider 1 dot ds. Now by the formula of integration, we can put s here, and the limit is from 0 to s. Now by the formula of integration, we can put v 1 plus 1 upon 1 plus 1. So v square upon 2, and limit is from u to v. Now we can apply the limit, upper limit minus lower limit. A s minus 0 equals to, take out 1 by 2 because we can't apply limit on the constant term. So apply the limit on v square. Here as 1 by 2 v square minus u square. Just take this 2 here. So 2as equals to v square minus u square. V square equals to u square plus 2as. This is your third equation. Is this proving is clear?
Yes, ma'am.
Is there any problem in any step? Simply you have to apply the formula of integration. Now just you have to consider this term. Just remember this term, and now the simple mathematics is here. Okay? Okay. So we discuss equation of motion by graph method as well as calculus method. Now we will do next proving distance traveled by an object in a particular second. Okay. Distance traveled by an object in a particular second. What does it mean? Like we have this second equation of motion. Right? S equals to ut plus half at square. Okay. So from this equation, we can find the displacement after t second. Okay. If let us consider the initial velocity is 0 and the acceleration is 10 meter per second square, and we have to tell the displacement after 5 seconds. Okay. So we can easily find out the displacement after 5 seconds with this formula. But here, if someone asks you what is the displacement in the 5th second, what is the displacement in the particular 4th second? So for that, we have to derive a formula, distance traveled by an object in a particular second. So let's see. Distance traveled by an object in a particular second, or we can say that in tth second. So let us consider we have a particle which have initial velocity u, and after time t it will gain final velocity v, and it is moving with a constant acceleration a. So initial velocity is u at t equals to 0, and final velocity is v at t equals to t, moving with constant acceleration a. Okay. So distance covered by the particle after t second. Distance covered by the particle after t second. So we have the formula s equals to ut plus half at square. So we can write like this. S in suffix we have to write t, because we are talking about here distance traveled after t second. So st equals to ut plus half at square. This is your first equation. यहाँ तक क्लियर है? यहाँ तक कोई प्रॉब्लम? Distance traveled by an object in a particular second, or we are talking about in tth second. So we have an initial velocity of that particular object is u at t equals to 0, and the final velocity is v at t equals to t, and that object is moving with a constant acceleration a. Distance covered by the object after t second, st equals to ut plus half at square. Now distance covered by the object in t minus 1 second. Okay, distance covered by an object in t minus 1 second. So we can write the formula like this: s, just place t minus 1 in the place of t, u t minus 1 plus half a t minus 1 whole square. This is your second equation. Is there any problem in the second equation? सी सिंपल सा एग्जाम्पल हो, अगर आपको ये पता है कि किसी भी पार्टिकल ने 5 सेकेंड में कितना ट्रैवल किया, और अगर ये पता है कि 4 सेकेंड बाद कितना ट्रैवल किया है, तो 4 से 5th तक जाने में वो जो लास्ट वाला सेकेंड है उसमें कितना ट्रैवल किया आप निकाल सकते हो इजिली. टोटल 5 सेकेंड में जितना ट्रैवल किया हो उसमें जितना 4 सेकेंड में ट्रैवल किया उसको लेस कर दो, तो वो जो पर्टिकुलर लास्ट वाला सेकेंड है उसकी डिस्प्लेसमेंट निकल जाएगी. Right? Is this example is clear to you what I am talking about? If I want to calculate the distance covered by the object in the 5th second, okay, and we know that and I know the displacement after 5 seconds, and I know the displacement after 4 seconds. So what can I do? I simply subtract that displacement, right? So we can find out the displacement covered in the particular 5th second. सेम थिंग यही करेंगे, सेम थिंग यही हमें करनी है. नाउ व्हाट वी विल डू, वी विल सब्सट्रैक्ट इक्वेशन 2 फ्रॉम इक्वेशन 1. नाउ distance traveled by the object in tth second. Okay, so s of t minus st minus 1. Simply you can write equation 1 minus equation 2. Okay, so now just go to this ut plus half at square minus u of t minus 1, and because minus sign is here, चलो इसको ऐसे ही लिख देती हूँ, half a t minus 1 whole square. Okay, now just open this bracket. So ut plus half at square minus u of t minus 1, and minus plus minus half of a t minus 1 whole square. यहाँ तक कोई प्रॉब्लम? Is this step is clear? Simply we have minus here, that's why minus plus become minus here. Okay, now ut plus half at square minus, just multiply this ut, and minus u minus 1 is plus u, right? Now 1 by 2 a, and here we have to apply the formula of a minus b whole square. So the formula is a minus b of whole square is a square plus b square minus 2ab. Right? Apply this formula. P square plus 1 square minus 2 into t into 1. ठीक है ना? इतनी मैथ सही लगी है ना? Now, this is your ut with a positive sign and this is ut negative sign. So we can cancel out this. Right? So half at square plus u. Now here just multiply this with this term. So this is your half a t square. Right? Now minus half a one square of 1 is 1, so just like this, and minus minus plus 1 by 2 a into 2t. Okay, is there any problem? Simple mathematics hai. Just multiply minus u in this term, so minus ut and minus u minus 1 is plus u. Then apply a minus b ka whole square, a square plus b square minus 2ab. Now just multiply this term in this term. So here we will get minus half at square and minus half a and minus minus plus half a multiplied by 2t. Right? Now plus half at square and minus half at square is cancelled. So u minus 1 by 2 a plus 1 by 2 a dot 2t. Now here we can take a by 2 constant. So I am taking plus of a by 2 so that I can write like this 2a minus 1. Okay, or you can write like this also. अगर कोई confusion हो रही हो, इस second term को पहले ले आओ, plus half a 2t minus half a, and just take out the half a as a common and 2a minus 1, and this is the distance covered in the tth second. Is this proving is clear? Simple mathematics है. Ut plus half at square minus u of t minus 1 plus half of t minus 1 whole square. Okay. Now ut plus half at square minus, because here is also plus, so plus minus minus half a t minus 1 whole square. So ut plus half at square minus ut and plus u, and here minus half of a, and just open the formula of a minus b whole square, a square plus b square minus 2ab. Okay, now you can cancel this ut and minus ut. Now here half at square plus u, multiply this half in this bracket, so minus half at square minus half a and minus minus plus half a into 2t. Now you can cancel minus half at square and plus half at square, right? So just u and here minus half of a and here plus half of a into 2t. Now I can write the second term here and the third term there. Now just take half of a as a common, so 2t minus 1, and this is the displacement covered by the object in tth second. So is this proving is clear? Any problem in any step? Is there any problem in any step? Just answer me in chat. I think if you go through the integration part, which I told you yesterday, and the differentiation lecture, which I delivered in last period, then there is no problem in calculus method. And this is the simple mathematics. यहाँ तो कोई calculus method लगा भी नहीं है. You have to just practice one. So I'm just repeating this proving once again. Here I'm talking about the distance which is covered by the object in a particular second. So just write the equation of motion that a object covered this displacement after t seconds. So we know the equation of motion. Second equation of motion, s equals to ut plus half a t square, right? For t second. After t second we can write like this. Then after t minus 1 second. Okay. So for t minus 1 second, just put t minus 1 in the place of t. Now just simply subtract the second equation from the first equation and do the simple calculation. You will get the formula s equals to u plus half a 2t minus 1. Okay. If there is any confusion, then just try this proving by yourself, because there is simple mathematics, nothing else. Okay. Now let's see. So all the equation of motion is now clear, I hope, by calculus method as well as graph method. Now, so we have three equation of motion. V equals to u plus at, s equals to ut plus half at square, and v square equals to u square plus 2as, right? So these all equation of motion regarding a straight line motion when any object is moving with a constant acceleration in a straight line motion. Now let's talk about the motion vertically downward to the earth or vertically upward to the earth. Here we are talking about this kind of motion, right? Now I want to talk about this kind of motion. When any object is simply falling freely towards the earth, then gravitational force comes into the role. And because of that force, this object feels a acceleration due to gravity, which is denoted by small g. And the value of small g is, come on, answer me. The value of small g is, the value of small g is 9.8 meter per second square. Okay, this is your acceleration due to gravity. It depends upon many factors. For Earth, the average value is 9.8 meter per second square, and for any other planet, the acceleration due to gravity can change. Okay, so we are talking about here Earth, so we will take this value, and sometime for simplification in numerical, we can also take g equals to 10 meter per second square if this is given in the question. अगर वैल्यू नहीं दी है तो हमेशा ये वाली वैल्यू पुट करेंगे. ओके, और अगर न्यूमेरिकल में वैल्यू दे दी है सिंप्लीफिकेशन के लिए तो फिर हम ये यूज कर सकते हैं, राइट? मीटर पर सेकेंड इज द यूनिट ऑफ वेलोसिटी, नॉट एक्सेलरेशन. जस्ट कंसीडर यूनिट equally important as well as your numerical value. Okay, so when we talk about the motion towards the earth or vertically outwards the earth, then the gravitational force play a role. Okay, and the object feel acceleration due to gravity. So in this kind of motion, we represent the, see, if any object is falling freely towards the earth, that means, and the gravitational force also try to attract this body towards the earth, so we are supporting the gravitational force, so we will use g in the place of a. Okay, we will use height for in the place of displacement. So the formula is HUT plus half GT square. In this case, V square equals to U square plus 2GH. Okay. So whenever we talk about the acceleration due to gravity, we use the equation of motion like this. We use small g in the place of A and h in the place of displacement. Is this clear? Is the equation of motion under acceleration due to gravity is clear? Okay. And whenever any body is going, this is for downward situation. And whenever any body is going in upward direction, that means we are doing work against the gravitational force, because gravitational force wants to attract the body and we are doing work to take out this body upward direction. So we will use minus g in the place of A. Okay. So in this condition, the formula is like this. This is for the when the object is moving in upward direction towards the, and when the object is moving towards the earth, and when the object is going outwards the earth. So this is clear?
Yes, ma'am.
Okay. So now let's do a numerical, which is a basically multiple choice question. The question is this: the velocity of a particle is given here in this question. Velocity is v equals to v naught plus gt plus at square. And here v naught, g and a, these are the constant. Okay, v naught is also a constant, g is a constant, not a acceleration due to gravity, it is some kind of constant, and a is also a constant. And you have to tell me the displacement after t equals to 1. In this question, displacement is 0 at t equals to 0. That means initial time, the displacement is 0, and we have to tell them the displacement at t equals to 1 second. Okay? Question clear है? Velocity की equation दी हुई है v equals to v naught plus gt plus at square.